Okay, so our next proof involving rectangles is to prove that the diagonals are congruent. So let's begin by drawing the rectangle, and don't get this confused with knowing from the previous problem that the diagonals bisect each other. While that is important, this proof wants us to show that the two diagonals have exactly the same length, regardless of the dimensions of our rectangle. So we have some rectangle, ABCD, and let's draw our two diagonals. Well, we know that we have a bunch of right angles, which means right triangles, and we know that opposite sides are congruent based on the results from the last problem. Now, we might be tempted to use the fact that diagonals bisect each other, but it's honestly it's not really too relevant in this problem, because looking at what we have now, we already have a triangle congruence with two triangles made up of the different diagonals. So for example, one of the triangles that has diagonal AC would be ADC. So let's look at triangle ADC. Now let's compare that to one of the other triangles where it contains the hypotenuse BD. So that could be triangle BDC. Now, are these two triangles congruent? Well, absolutely. Because we have that both triangles contain this side X length, AD and BC have the same measure, and both triangles contain this side DC, and they both contain a 90-degree angle between the two. So we have that these two triangles are congruent by side angle side congruence. Now, because this is true, the corresponding sides must be congruent. And we know that AC is the hypotenuse of ADC. Therefore, it's going to be congruent of the hypotenuse of BDC, which is BD. This is by CPCTC. And that is the entire proof. Because logically, we have justified that since triangle ADC is congruent, is the same thing as BDC, the corresponding parts are the same. And the corresponding parts of right triangles would be like the hypotenuse is the hypoteni. So the two hypotenuses, AC and BD, are the same. Hence, they're also the diagonals of the rectangle, and we have shown that they are congruent. A fairly simple proof.